Hello, Algebra 1 friends. Today we're going to be graphing quadratic functions in vertex form. So if you would please turn to 9.6 in your notes packet, we're going to start there. So the first thing that I would like to do is actually kind of revamp and re-talk about what we did on Tuesday. We did a transformations discovery. So if you will actually turn to page 11 in your notes packet, we're going to just kind of debrief the major transformations and the major parts of each of this equation. So the parent function for this unit was y equals x squared. Everything that we have done has revolved around x squared this unit. So on Tuesday we learned that the a value does three very important things. If it's negative, we think about, okay, if my a value is negative, it's going to go downward like a frowny face. And this is called a reflection. If a is greater than 1, it's going to stretch my graph. If a is less than 1, it's going to compress. All right. Sorry about my voice. Been a little sick this week, so I'm really sorry. I apologize. Bear with me. All right, if we think about the next portion of that discovery activity, we looked at like x minus 5, for example, and we looked at like x plus 3. Anything that's happening on the inside of the parentheses, you want to think of as being opposite. So instead of a minus 5, this is actually going to go to the right 5 units. And then instead of plus 3, this is actually going to go to the left 3 units. And then your k value is whatever's happening on the end. So this is going to have a vertical effect. This is going to have a horizontal effect. So horizontal meaning we're moving left, right. Vertical meaning I'm moving up or down. So if we have a positive k value, that's going to shift our graph up. If we have a negative, that's going to shift our graph down. And that'll happen at the very end of the equation. Okay, so before I dive into graphing, I want to talk about the parent function here for just a second. There's a special pattern that happens with this function, and we can use this pattern to plot points very easily. So I want to think about, okay, where does x squared start? If I allow x to be 0, then 0 squared would be 0, so I know I'm going to start at the origin. If I allow x to be 1, 1 squared is 1. So now I'm at the point 1, 1. If I allow x to be 2, 2 squared is 4. So now I'm going to go up to 4. If I allow x to be 3, 3 squared is 9. So now I'm going to go all the way up to 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know this isn't perfect. I just grabbed a piece of scratch paper. But I wanted to prove a point. So we know that parabolas are symmetrical, right? So these points, I can put them in a different color. These points are going to get reflected over on the other side. But what's cool about this function is that the rate of change happens in a pattern. So when we look at starting at the vertex, to get to the first point, I went up 1 over 1, kind of like slope. So rate of change is kind of like your slope. So to get to the first point, we went up 1 over 1. And then to get from this point to the next point, we actually go up 1, 2, 3 over 1. So So now I'm starting here. So now to get to the next point, we had to go all the way up to 9 over 1. So we went from 4 to 9, which is an increase of 5. So I bet you can guess what's going to happen if we keep going. Excuse me. So that pattern is going to continue, and we can use that to plot points very quickly. So let's look at the front here just for a moment. Standard vertex form looks like this. We have a x minus h squared plus k, where the h and the k are the vertex, which means the axis of symmetry is connected to the vertex, right? And how do we write axis of symmetry on our quizzes? X equals. So in this case, your x is equal to your h value. So those two should always match. They're always going to be the same. Okay, now remember, we said anything on the inside you have to think as opposite, right? So instead of a positive 4, think about your transformations. Instead of plus 4, this is actually going to transform to the left. So I'm going left 4 and then down 2. So my vertex is at -4, -2, which means my axis of symmetry is -4. All right, in this case, I have -3, but I want to think opposite. So this is actually going to go to the right. And then what's my k value? Is there a number on the end? No, there's not. So k actually equals 0. So I'm going to go to the right 3, and then my k value is 0. So this is going to be x equals 3. Okay, let's think about this one. -5, but I want to think opposite. So instead of going to the left, we're actually going to go to the right, and then this is going to be down. So this will be 5, -4. Is there an h value in the parentheses? No, there is no parentheses, so our h value is 0. So we're going to go 0, 3, which means x now equals 0. Okay, couple quick steps to help you when you're graphing. Step number 1, it's called vertex form for a reason, because we can identify the vertex. Okay, so identify and graph the vertex. And then after that, you need to graph the axis of symmetry. Those two are connected, right? And then you're going to use the pattern 1 over 1, 3 over 1, 5 over 1. And sometimes we'll have to multiply by the a value. But this gives you your new point. So this is your rate of change. Rate of change. Okay, and then step number 4, plot these new points. All right, let's see it in action. We call it vertex form for a reason, because the vertex form is super easy to start with. So remember, we have to think opposite. So instead of left, we're actually going to go to the right. So I'm going to be at 6, 5. And then this a value is going to cause us to go down. So I'm going to count my slope. So I'm going to go down 1 over 1 for my first point. And then from there I have to count down 3 over 1. And then from there I have to count down 5 over 1. And we have a beautiful little parabola. And we're going to make an XY table for that. So this is, let's see, I'm just going to start with 4, 1, 5, 4, 6, 5, and then we landed at 7, 4, and 8, 1. All right, pretty cool, huh? Okay, let's try number 6. Vertex. All right, we don't have any h value here, so this is going to be 0 for the h, and then this is our k. So now we're at -3. So I'm going to go to 0, -3. And now my a value is 2. So what's going to happen is these patterns are going to get multiplied by 2. So now I'm going to be looking at 2 over 1, 6 over 1, and then 10 over 1 to find our new points. So I'm going to go up 1, 2 over 1. And then from there, I have to count up 6 over 1. Because again, the 2 is stretching, right? So think about it like stretching Play-Doh. It's going to get really tall and skinny. So I'm going to go up 6. 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And then if I go up 10, I'm going to be off my graph. So I'm just going to stick with that for right now. All right, and then let's write down where do we end up. So it looks like I'm at -2, 5, -1, -1, 0, -3, 1, -1, and 2, 5. All right, stay tuned for the next part of the video. I'm going to take a little break to go to Mathletics, and we'll be back. Stay tuned.